Well, I'm very glad you played that video. That made me feel like I needed to stand up and salute, actually, because I'm also going to talk about deep learning solutions. And I'm going to talk very specifically today about using deep learning solutions on Power 8 with P100 and NVLink. So by way of introduction, my name is Scott Suter. I'm part of our product management team within IBM. I have two products. One is our deep learning solution, and one is an accelerated database solution. So we heard a great example of that earlier today. So this is sort of an existential question. How do you teach a computer to perceive? I mean, programming a computer to perceive is a virtually impossible task. But what if we could teach a computer to learn? Teach a computer to go through a very similar process to what you did as a child when you figured out, well, what's a bicycle? What are the characteristics of a bicycle that are unique? How's it different from a motorcycle? How's it different from a car? This is something that we do intuitively through a neural process, and it's something that's replicated through what is called deep learning. And I'll back up just a little bit. Deep learning is a subset of AI and machine learning, and it is really designed around the idea that if you put a mini-layered neural process in place, you can teach a computer how to learn. It will sift through millions of different items, different data points, and it will learn to figure out which are the important ones. And so it is also, as Tim mentioned, something that has been phenomenally successful and has phenomenal uptake on GPUs. And luckily, we have a good place to put a GPU. So this is really a tale of two different infrastructures within deep learning. There is the training aspect, which is that neural network analysis. And then there is the inference piece, which acts on what the system has learned, acts on a fully built neural network. Today I'm really going to talk about the data center part of the equation, which is the training element. And I'm going to talk about how that works today on the IBM S822LC for HPC, well known and loved as the Minsky. So IBM's strategy around deep learning is really comes down to three things. First of all, this is adjacent to what you would probably first think about when you consider IBM and AI. We're adjacent to Watson. We think that's a great solution. But there's also a vibrant community out there of open source developers sponsored by very large entities who are adding tremendous innovation into the space. Our offering around deep learning is very focused on this. We are working with the deep learning distribution or frameworks, modifying them and adding innovations. So we're trying to help change the frameworks. We're trying to add additional capabilities, such as give them the ability to scale out. And then also, as a systems provider, figure out how to build differentiated GPU accelerated systems that use NVLink and give the unique capability that that brings to intra-system communication to help speed up the neural networks. So what are we doing? We have created two versions of this already. We're about to drop number 3. And what we have done is built a distribution of the 4 most popular deep learning frameworks: Caffe, Torch, Theano, TensorFlow, and some of the libraries that support their operation within a Linux on Power system. We are making these available, and we're upstreaming the port to the open source community. We want to expand the world here. We are also starting to add innovations from IBM into these libraries. We're adding innovations from our research institute, institutes around the globe, and our systems institutes to help bring more capability to the neural networks themselves. We won't be upstreaming all of those, but we will be making them available at IBM.com. And we are pairing these up with systems that are generally available today. Pairing them up with the Minsky systems that are started selling last quarter and are available from your IBM business partner, from IBM Direct, or systems that are enabled with IBM P8, NVLink, and P100 through your OpenPOWER partners. And we are right around the corner from having our initial availability of the frameworks, and I would not be surprised if we said something very big in the next couple of weeks. So our first goal with developing this, we need to simplify access and installation for these products, especially on an architecture that has unique capabilities such as Power. We want to make sure that all of the underlying libraries and software frame capabilities that come out in CUDA, CUDNN, and then some of the mathematical accelerators are available, optimized, and see the benefit of NVLink. We want to simplify the installation process, make sure that this is as easy as getting either a single deb package and being able to put it on your Ubuntu system, or bit by bit build it from source with a set of instructions that we will make available on the OpenPOWER Foundation webpage. And then over time, again, as I mentioned earlier, optimize. Bring more of our IP into this, find a way to improve the networks, build them into an infrastructure that scales out better. We heard a little bit about NVLink earlier, and I think that the important point that I want to add here, not only in building this very balanced system do we create the capability to move data through the system very quickly, but it reduces significantly the latency that you see within a deep learning training scenario. We can move roughly 4 times the data between GPU and memory using NVLink and using those 40 gigabyte bidirectional connections between the POWER8 CPU and the GPU as you can on a PCIe system. We measured the results at about 4 gigabytes per second using PCIe attached GPUs and 17 gigabytes a second using NVLink attached GPUs. What that gives you is a significant reduction in communication time. And what that brings you today is the ability to run your neural networks faster. You can either include more data in your training routines, or you can close out your work quicker. But it's a very tangible expression of where NVLink brings the benefit of lower communication time to your compute. And this is before we start talking about some of the benefits of the P100 GPU itself, which is a tremendous tool for deep learning. So in practice, what that has given us is a system that is about 2.2 times faster than the previous generation of an M40-based deep learning system. That's pretty good for a one-to-one comparison. What I don't show here is that a 4 P100 NVLink system is about 30% faster than an 8 GPU M40-based system. So again, tremendous increase in capability, both through the P100 enhancements, but also through the capability of NVLink. So as a company, we really wanted to focus on creating business value around deep learning. We see our opportunity here as helping enterprise customers who are all thinking about how they're going to attack this problem, find a way to put it into production. So we bring the value of helping the data scientists get to production quickly, reduce that training time through enhanced performance, reduce that provisioning time through simplification of the packaging and of the distribution. We also bring a remarkable amount of flexibility to your infrastructure. The Minsky systems are extremely cost competitive, so when you look at them versus a more purpose-built purpose-built deep learning system like the DGX-1, you can see that you can get roughly 2 for 1, two for the price of 1, which is a heck of a deal. And even more important, these are flexible systems. They can be a part of your HPC infrastructure. They can be a part of your deep learning infrastructure. They can be core to your accelerated database and OLAP infrastructure. And also importantly, we're first to market. Because, as Tim mentioned, we had the foresight to recognize a fantastic technology. We are now about 60 days into selling our Minsky systems, and so this is probably the best, quickest, and I would submit fastest way to get yourself a hold of a P100 GPU. I will be available here to talk a little bit more about the offering. I'm happy to talk at more detail about what went into some of the benchmarks, because I understand that those could be technically interesting to folks, and I really appreciate your time. Thank you.